Another edition of Your Notes. Welcome back, geometry students. And no, your video is not upside down. My paper is. Now we're ready to go. Today's notes are changing dimensions with area. There are quite a few things to write down here. Let's make sure we get them all into your journal. Also, don't forget to answer the WSQ. Here we go. All right, so we're talking about dimensional change, mainly with proportional dimensional change. You can change when things are not the same dimension, not the same proportional dimension. But in that case, all you have to do is just figure out what change the change happens to, or what happens to the change when it happens. Doesn't make a whole lot of sense when I'm saying it to myself, but just you got to do it. You got to work it out. Okay, we're talking about things whenever it does change proportionally. Okay, so let's talk about this. Things are going to multiply, or what happens is, it multiplies every dimension by the same value or ratio. So the same ratio is changed every time. Another word for ratio is also scale factor. So things are changed by the same ratio, same scale factor each time. The image, which is the new thing, and the pre-image, which is the old one, both those figures are similar. So if they're similar, we can find the ratio between them. We can use proportions to go back and forth, stuff like that. Here is the key concept. You must get this part. If the scale factor of two similar figures is considered to be a over b, then the ratio of their perimeters is also a over b, and the ratio of their areas is a squared over b squared. Okay? My plan is to get some examples in class and do this together, but here's an example here with this trapezoid. If we found the area of this trapezoid, or more so the perimeter, find the perimeter of this trapezoid, 11, 5, 5, and 5, added them all together, we have 15, 26, right? And then if we cut it in half, take everything half, we have 2.5, 2.5, 2.5, and 5.5, we should get 13. So the perimeter is also half. But the areas is not just half, it is half squared, or 1/4. And we can actually find that out, just to prove it, that first off, the area of the original trapezoid would be 32, and then if I take half of all the dimensions, now I have 2.5 and 5.5 and 2, so the new area would be 8, and 8 is not half of 32, although I only took half of all the dimensions. 8 is 1/4 of 32. So you can see that that's going to happen with these ratios. Let's use those ratios now. The best thing about this, if you get this key concept, you no longer have to find the area of everything and compare the two things, or do all the math necessary. You can just use this thing. The way I remember this, though, is that we know area is square units, so therefore take the ratio and square it. A little bit of a preview then. If we're changing volume, the volume is cubed, so the change in the volume would also be the change cubed. All right, so we'll get that later. All right, let's look at example 1. It says the trapezoids are similar, and it wants us to find the ratio, the perimeter ratio, and the area ratio. Notice I can't really find the perimeter. I can't find the area. Not everything's given to me. But using this key concept up here, I can find all of this. All right? So the ratio from one trapezoid to the next would be the 6 over 9. And I could simplify that to get 2/3. Divide everything by 3. So the ratio from one trapezoid to the next is 2/3. All right? And notice that the perimeter ratio would be the exact same thing. If I added up all the sides, the perimeter ratio would also be 2/3. And then to find the ratio of their areas, I got to take this 2/3 and square each piece. So 2 squared over 3 squared would get me 4 over 9. So the ratio from of their areas is 4 to 9. This trapezoid is 4/9 of the area of the larger trapezoid. Okay, next example, example 2. The area of the smaller rectangular pentagon is 27.5 centimeters squared. It wants us to find the area of the larger rectangular pentagon. Okay, so I've got 4 centimeters and 10 centimeters there. And since these are regular pentagons, I know they're similar. I'm going to write that down. Since regular pentagons, they are similar. Right? All regular polygons of the same shape are going to be similar to each other. So once it tells me the area is 27.5 centimeters squared of the smaller one, It wants to know what is the area of the larger one. Okay? So to do that, I'm going to need to find the ratio of the two figures and then find the ratio of the areas. Okay? Because if I know the ratio of the areas, I can just find the new one using a proportion. Well, I can use the ratios of the figures, since the ratio, which would be just my A over B, would be equal to 4/10, or 4 over 10. That simplifies to 2/5. So this pentagon is 2/5 of the larger pentagon. With that ratio, then I can find my area ratio. The area ratio would be A squared over B squared. So that is 2 squared over 5 squared. So I get 4 over 25. The ratio of the areas is 4 to 25. So with that, and with one of the areas, I can set up a proportion to find the ratio of the larger pentagon. So 4 over 25 is going to be equal to, I have the smaller one. One way you know where this one goes is you know it's a smaller pentagon, so it's going to go follow the smaller number. So 27.5 is a smaller one. I don't know the larger one, we'll call that x. So to do this, I got to cross multiply. 4 times x is 4x. 25 times 27.5 is going to get me 687.5. Divide by 4, so x will get me 171.875. I already did the math ahead of time, had those numbers written down, saved us some time. So this is going to represent my larger area. So my area is 171.875 centimeters squared of the newer pentagon. So much easier than finding the area of each one, although you could do it. I could find the area of the smaller pentagon, find the area of the larger pentagon, and then compare them. But here I found it a simpler way. Last example, it says the areas of two similar triangles are 50 centimeters squared and 98 centimeters squared. What is the ratio of their perimeters? Okay, so in this case, it gives me my ratio of the areas, A squared over B squared. I need to find the A over B ratio of their areas. So if A squared over B squared, in this case, is equal to 50 over 98, first, it'd be easiest to simplify 50 over 98. So A squared over B squared, and now divide both by 2 is 25 over 49. Now you might see why I wanted to simplify those, because to find my A over B, just take the square root of both sides. And then in essence, if you're taking this, it's going to be the square root of A squared over the square root of B squared would be equal to the square root of 25 over the square root of 49. And then I would get A over B, nothing there. A over B would be equal to 5 over 7. So the ratio of the perimeters is given to me as 5 over 7. And you could, if you wanted to, just go straight to the calculator with the original values, find the square root, find the square root of a fraction. What was it, 50 over 98? Yeah, 50 over 98. And that gives me 5/7. But even without a calculator, I could do it that way by simplifying them and realizing I have some perfect squares. Okay? Make sure you watch this video again if you feel like you need more help with it. Again, this is the key concept. We're going to give some more practice in class. Also, there's other videos available for you on Sophia. Not Sophia. That's what I use. On YouTube. There actually are videos available on Sophia. You could search for them there. And make sure you finish the WSQ. Have a great day.